that we are in this thoracic cavity. So here's the way that the wrappings, these tissue wrappings are going to be. Basically when we look at the structure, okay, we're going to find that our lungs have a lining that sits in a cavity that has a lining. So our lungs are in what we term the pleural cavity. The pleural cavity is that wrapping around each lung. That wrapping around each lung individually has fluid in it. The pleural fluid. Ever heard someone have pleurisy? No? Okay, you're going to come across that when you get out into the medical field. This is the point at which that problem occurs. It occurs in this pleural cavity with the fluid in that region. We have our visceral pleura, and you can see where they tried to color code everything for you. So around the lungs, I've got a visceral pleura. Now, this one is also simple squamous, serous, meaning therefore secretes fluid. We have a parietal pleura. If we look at the parietal pleura, this is the point that we're going to have connection to my thoracic wall itself. Does everybody kind of see how they're representing the rib cage cut out? Okay. The fluid that's going to be present in this region helps to hold stuff together. You can see that we'll have a membrane that will line the area with the diaphragm, because we need to make sure that as that diaphragm expands and contracts, all right, that we're not having friction at that point either. Okay, so we've got our lungs, that viscera, which is in a wrapping, of the thoracic. So we get this really cool place that's called the pleural cavity. The fluids surrounding are very important because they are going to be very good at reducing friction. People who have certain health conditions, fluid can build up in those areas to the point that the lungs collapse and they actually have to go in with tubes and drain it. Yes. Sometimes they may have to surgically insert a tube that's going to stay in for an extended amount of time. Especially, like, for example, people who have certain lung cancers, well, lung cancer in general, are going to build up fluids on their lungs. That tends to be a huge issue with the lung cancer. So, how is it that we go about breathing? Well, we have what's called the respiratory cycle. You guys remember the cardiac cycle? One event of contraction and relaxation. The respiratory cycle is one event of what's called our inspiration, breathing in, and expiration, breathing out. We have what's called quiet versus forced breathing. Our muscles of respiration are going to be our intercostal muscles and my diaphragm. The muscles of the diaphragm look like this so that they can expand and recoil, expand and recoil. And luckily, in the lungs themselves, especially at the point of the alveolus and the tubes leading up to that, have the ability to expand and recoil. Very elastic in nature. Okay, elastic tissue is very much present. So, what we get, okay, some of our skeletal muscles come into play. You guys remember my good old sternocleidomastoid? Okay, the scalenes, all right? You guys remember looking at the intercostals? You didn't have to learn a whole bunch about them because they're deeper muscles, okay? They're they're deeper than what we would think of as the actual palpating. The pec minor comes into play. Our diaphragm, definitely. Now, expiration, we've got intercostals again, diaphragm, my rectus abdominis comes into play, and my obliques. So, breathing in, breathing out. Ever paid attention to it? What type of breathing do we do mostly?
Go ahead.
Deep or shallow?
Shallow.
Shallow. Is that good? Not really. But we also can't sit around all day paying attention to our breathing cycle, okay? So what is it? How are we going to get the control of breathing? Even though we can see lots and lots and lots of skeletal muscle present, something else takes over. Take a break. Be back at 9:30.